Everything inside a computer, numbers, text, images, music, even this video, is made from only two symbols, 0 and 1. And this is just the topic of the first unit of IGCSE Computer Science. You've chosen to study IGCSE Computer Science. But here's the question. Why does it start with a chapter called Data Representation? When we hear the name computer science, we might expect to start with things like hardware, software, or programming. But computers exist for one main reason: to process information. And before a computer can process information, there is a more fundamental question. How should information be stored inside a computer? How do computers record numbers, text, images, and sound? That is exactly why data representation appears in the first chapter. The answer is surprisingly simple. Computers represent all information using only two symbols, 0 and 1. But how can just two symbols represent everything? Before we answer that, let's first look at how humans represent information by symbols. Take numbers as an example. There are infinitely many quantities that we may want to describe. At first, it may seem that we need infinitely many symbols. But in the decimal system we use every day, we can represent any number by combining these 10 symbols. Each symbol represents a quantity. 0 means none. 1 means 1. 3 means 3. It does not matter whether we are counting apples or people, because quantity itself is an abstract idea. Now let's look at the number 13. In the decimal system, we write it as 13. Why do we write 13 this way? Because in decimal numbers, the value depends on two things: the symbol itself and its position. In the number 13, the 1 is in the tens place, so it represents 110. The 3 is in the ones place, so it represents 3 ones. So the number 13 really means 110 plus 3 ones. That gives us 13. Now let's try a larger number. For example, 4,213. This number means 4 thousands plus 2 hundreds plus 110 plus 3 ones. But why does the 4 represent 4 thousands? Because the 4 is just in the third position from the right. And 4,213 is a decimal integer based on 10. So that position represents 10 to the power of 3, which equals 1,000. And the 4 here represents 4 times 1,000. Using the same idea, the other digits represent how many 10 squared, 10 to the power of 1, and 10 to the power of 0 are in the number. Now here is an interesting question. Can we represent all integers using only two symbols? Just 0 and 1? The answer is yes. And this is exactly how computers store numbers. This system is called binary. Binary follows rules very similar to the decimal system. Let's represent 13 again, but this time using binary. In binary, 13 can be written like this. This number represents 12 to the power of 3, plus 12 to the power of 2, plus 0, 2 to the power of 1, and 1, 2 to the power of 0. If we add these together, the result is 13. So we can see something interesting. With just two symbols and a set of rules, we can represent all integers. Understanding binary numbers and learning how to convert between binary, decimal, and hexadecimal is the main topic of Section 1 in Chapter 1 of IGCSE Computer Science. But numbers are only one type of data. Can computers use 0 and 1 to represent other information? Of course we can. This idea does not only apply to integers. Various characters such as letters, Chinese or emoji, as well as images, sound, and even numbers like negative numbers or decimal fractions, can all be represented using nothing more than combinations of zeros and ones. Thank you for watching this video. Welcome to get free exam-ready answers in my bio.